subscribers. Got to get it 1,000. All right, yes, those of you who said -7, well done. You have been granted passage into mathematical heaven. Now, g of -7, that's next on our list. That'd be -7 plus 1, also known on the street as -6. Okay? So, those are the answers to question 11. We had 5 for the first one and -6 for the second part. I didn't do that example because I thought that was Algebra 2-ish. I thought you guys would handle that, but I've seen a couple people make mistakes with that today, or just not doing it at all. So, I want to do question 18 for sure. Somebody asked me about question 22 as well. Question 18. So let's look at f of g of x. All right. So the f function's the one on the outside, controls what's going on. It says whatever you plug into it, it's 1 over that thing minus 1. Okay? What are we plugging in there? According to this, g of x would be the square root of x. So what are we plugging in? Radical x. This would be your unsimplified form. This is where you check domain issues. Graphing it is not a bad idea. But you should all know something about x because it is inside the radical. What do you know about x? Can't be negative. Now, people keep saying that, can't be negative. Why don't they just say greater than or equal to 0? I don't get that. I mean, like, period after period after period. Can't be negative. I'm like, come on, greater than or equal to 0. Yeah, but I got to get people to, like, take the next step. Yeah, exactly. Okay. So now, if you take the denominator, oh, wait a sec. What's wrong with that? I just wrote something wrong, didn't I? Wrote something wrong. What did I write wrong? The denominator cannot equal 0, right? I should have had not equal to 0, right? Totally my fault. All right, now, if you add the 1 to the other side, that means the absolute, or the square root of x cannot equal 1. And then what do you do to get x by itself? You square both sides, right? If only we knew what 1 squared was. Oh my goodness. Take the dagger out of my chest. All right, now, you need to put these two things together. X is greater than or equal to 0, but it can't equal 1. Didn't that just take your 1 interval and split it into 2? Go look at your picture. Graph this thing. Yeah, it's so hard to graph. Attacked? What do you mean attacked? Are you kidding? We had that whole unsimplified, simplified thing going on. That was great. That's right. Paying attention, participating. You figured eventually we'd get useless, useful. That's the one. Yeah, man. You knew eventually you were going to be right. Okay, so you graph this doggone thing. Does it look like it's in 2 pieces? You should have some sort of picture where it looks like it's down here, dropping off the face of the planet, and then something like that. So what's the domain? Put these two things together and come up with the two-piece domain. Closed or open bracket on 0? Closed. Right? This guarantees that it's closed because it says equal to 0. Comma what? 1, bracket or parenthesis. Has to be parenthesis because that's where the break is. Union what? 1 to infinity. Because it keeps going that way for a long time. So we have a broken domain. The picture helps you understand that. But the algebra also verifies it. Now what happens when we flip things around? G of f of x. Of course, yes. So the part on the outside is controlling what goes on. The g function for question 18 says whatever we plug into it, we take the square root of that. And what are we putting into it? The f function 1 over x minus 1. Well, what do we know about x minus 1? X minus 1 cannot equal what? 0. So that means x cannot equal 1. And what do we know about 1 over x minus 1? It has to be greater than or equal to what? 0. Whoa. That's going to make for some interesting stuff. Square root alpha y equals, put a fraction, 1 over x minus 1. So you're looking at some sort of picture. What I don't know is if it's stopping or if the pixels are just that bad, and is it stopping or is it an asymptote? So like if I hit the trace button and I'm going to type -1, I hit the trace button, I type -1, there wasn't anything for y. What's that mean? It's an asymptote, thank you very much. So this thing's getting closer and closer and closer to that vertical asymptote at x equals -1. So what's that mean about my domain? One to infinity, including 1 or not? Don't you dare touch the asymptote. Seriously. Okay? That whole thing right there should have stopped you from touching it. X does not equal 1. Okay? 22. See if we can do at least part of this before we move on. Was there one particular part you wanted? Was it f of g of x? Or the other? Was 21? My apologies. And which one was in particular the difficult part? Or both?
I got all the reals for the domain.
Okay. F of g of x. We'll start with this one. So the f function's the one on the outside. And it says 1 over 2 times whatever you plug in. And we're plugging in g of x, which is 1 over 3x. Are those parentheses useful or useless? They are useful because you're multiplying them by 2. What do we know about 3x? It's in the denominator, folks. What do we know about it? It cannot equal what? It cannot equal 0, therefore x cannot equal 0. If you divide both sides by 3, you're not changing that fact. We also know that 1 over 3x cannot equal 0. But that's never going to happen because the top's a 1. There's no way I could get the top, this thing to equal 0 because no matter how big x got, I would still have a positive value. So that doesn't even come into play. So far, the only thing I know from looking at this algebraically is you can't get a 0. So I know all reals is not a completely correct answer. So, graph it. If I were you, I would... Now, if I'm doing this on the old school version, I've got 1 divided by, so if I've got my y1, 1 divided by parenthesis, 2, parenthesis, 1, parenthesis, 3x. Man, this is nasty looking. That would be that's my version on the old style calculators. Versus the new style calculator, which you could make the doggone thing look just like this, which is super duper nice, to be quite honest. Oops, I did that wrong. That's not what I said. Whoa. Folks, look like something like a line like this with a big old hole in the middle. Yeah, it's a removable discontinuity, folks. That's kind of a weird one. So your domain for this would be what? Negative infinity to 0, parenthesis or bracket, parenthesis, union, 0 to infinity. Everything except 0. I have a very similar feeling that you would get a similar result if you switched those, because those are very similar looking fractions. So, yes, you can simplify that. That would be the same thing as, let's see, 1 divided by 2 times, what happens if I did that? 1 over 3x. What if I multiply the top and the bottom by 3x? What if I multiply the top and bottom by 3x? What happens right here? Whoosh, gone. So we end up with 3x over 2. Oh, look, that's a line with a slope of 1.5. Okay, that makes sense. It's a linear function. It just can't accept a 0. That makes sense. Make sure you look at your graphs. Okay, we need to finish up the notes from this section. We had a last example to go through, I believe. This was our last one in the bunch. Are you familiar with angioplasty? pretty sure you haven't had it done to you. Do you know if this is a permanent fix or a temporary fix?
Temporary.
It is a temporary fix. So you have a vein. They basically put a little balloon in there, blow it up to kind of push back some of the cholesterol so that your veins can breathe, basically, and the blood can flow, right? Yeah, so you don't have a heart attack. Yes. Yeah. So they insert the catheter with a little balloon. It's a spherical balloon, and they blow it up basically to do the procedure. Okay. Well, there's this guy on the other end going, too much, too much! You know, and they were like, oh, we lost it. Yeah. You know, I mean, guys go to school, ladies and guys go to school for this kind of, you know, precision balloon blowing up, you know? That or being, yes, making the animals, yes. So those are your two choices. I mean, it depends. If you're at the top of the class, then you get to do it with, you know, people. All right. So if you don't do this, then you're at parties doing the little balloon animals. Okay. All right, now.
I might as well just drop out now.
What is the volume formula that you remember from geometry class? Pretty much they don't remember, do they? Something about 4/3. 4/3 pi r cubed. Yeah. All right, nice. I wouldn't have said that out loud. Okay. No. You know what? I wish that more people would realize in life, as you get older, I hope that you realize this, that there is no shame in redoing something to get better at it. I wish kids, for instance, I wish kids, instead of taking the next class and making their life miserable, would redo the last class and get a much better grade and understand Algebra 2 before they try to attack pre-calc. Because some of you are going to struggle a lot with this stuff because you were okay at Algebra 2 and now you're in the big leagues and this is not going to be fun. So, there's no shame in that. That's it's okay. It's okay. All right, now, it says in this particular problem, the constant rate that they're blowing this up at is 44 cubic millimeters per second. So whoever's on the other end of this balloon is pretty good. I mean, a constant rate, nice. Okay? So that means that the volume is increasing 44 times every second. Okay, part A says find the volume after t seconds. Ding, ding, ding. We just did it. We wrote the equation. Yeah, I know. Part B. Now, maybe I should ask you this question. Do you see that the eventual goal is not to be shopping? If you can't handle it, don't use it. Do you see a common variable that you can use to tie these two equations together? Do you see a common variable that you can use to tie these two equations together? The volume, right? That's eventually what we're going to be handling, is putting these two equations together with the common variable. But part B says, when the volume is V, what is the radius R? In other words, they want you to solve that equation on the left for the radius. So what should we do?
Should you do 4/3 times pi and then like
Yeah, you got the right idea. How do we start moving this stuff to the other side? Like, what are you going to do with this thing? Times, let's do 3/4. I know. Division is the same as multiplying by the reciprocal. Okay, so now we got pi r cubed. How do we get rid of the pi? We divide by pi. Also, the same thing as multiplying by what? Remember from middle school? 1 over pi, thank you very much.
You're welcome.
Multiplying by 1 over pi. So that, on the top, we got 1 times 3v. I'll do that one, that's hard. 3v. And on the bottom, 4 pi. Equals r cubed. Now we do that cube root thing. Yes. Let's switch to something else. Cube root. So for part B, r equals the cube root of 3v over 4 pi. Write an equation that gives r as a function of the time. So in other words, when we get done, you're only going to have an equation with r and t. There will be no volume involved. So, what do you think you're going to do with this and this? Substitution, thank you very much. What shall we substitute for v? 44t, go. Get it done. Substitute for v. So I hope that you plugged in a 44t. And then you know what I hope you did? I hope that instead of multiplying 3 times 44, you said, oh, look, 4 goes into 44 11 times. So that I could do this without a machine, right? So I got the cube root of 33t over pi. That's a bad looking 3. Let's okay. So that's the first part of letter C. Then it says, what is the radius after 5 seconds? Okay, so radius cube root 33 times 5 all over pi. And this is the part we probably need to do together because some of you are staring at your graphing calculator not knowing how to find a cube root. So, share my machine. Plugged in. Is it plugged in? No, that's not the right one. Alright. So, come on. Initialize. Okay, so 33 times 5. You guys got that part? Okay, and then you divided that by pi. Does anybody not know where the pi button is on your graphing calculator? That'd be a good time to ask me since they asked me second period. Everybody knows where the pi button is? I'm so proud. Okay, you got the pi button, everybody, to this point. Now you want a cube root. Type the root that you're looking for. It's a 3. Type a 3. Okay? Then you hit the math button, which is on the left side of the screen near the alpha button. Now, I realize the fourth one in the list is a cube root, but I'm not going to use it. I'm going to use the fifth one down, The reason I use the fifth one down is it's more universal. You can use it for fourth roots and sixth roots and seventh roots and all the roots. Okay, now on the newer style calculators, I'm sorry for you older fans out there, you don't get it. Ours actually replaces the index on the root. Yours just puts it in front, but that still does the same thing. And then, of course, I want to use the answer feature because there ain't no way I'm typing that thing in again. So 3.74. 3.74. Answer button down by the negative at the bottom. Yep. Good question. Yes. Are we going to figure out number 31? Oh, yeah, I can come back down for a second. I'll have to look at 31 because I'm not sure what it is here. These copies up and down here. Okay, all right. 31. Expands as it rises due to the drop in atmospheric pressure. Suppose that the radius increases at a rate of 0.03 inches per second. Okay. So the radius increases at 0.03 t. R equals 48 at times 0. Okay, at times 0 means that they just gave me this equation. They gave me the y-intercept. Determine an equation that models the volume of the balloon at time t, and determine when the volume. Okay, so volume equals 4/3 pi r cubed. So I'm guessing that they want me to substitute this in for this. And no, I am not going to FOIL that out. Okay, we're just going to leave it as is. Did you understand where I got the plus 48 from? They gave me the y-intercept. So they just want me to do the substitution. So now it says determine an equation that models the volume V at time t. Find the volume when t is 300 seconds. So we just put 300 in here for t. Okay. Makes sense? Yep. Type on the machine. Okay. Look at your calculator again. So we'll need something tomorrow, and I need you to be able to find it with me. Okay? Now, on your calculator, when you go to y equals, you see all these y1, y2, and so forth. Okay, do me a favor and go to the mode button, right? I refer to it as the Edna button. Edna mode? I mean, come on, folks. That is Incredibles humor all over it. Seriously. Okay, now, go to the mode button. I want to show you what we're going to be using tomorrow. Tomorrow we'll be using something called parametrics. So, for those of you with the old style calculator, it just says PAR. So you will need to be able to choose. When you choose this, go back to your y equals and take a look at it. Okay? It looks different, doesn't it? So we are going to deal with this. Now, when you hit the xt theta n button, instead of it giving you an x, it's going to give you a t. Now, just so you are able to do your homework, if you're catching up on things, go back to mode and switch it back to function so you can go back to what you know and love, and then we will do the parametrics tomorrow.